In this short talk, I will present TactiHelm. TactiHelm is a helmet that provides haptic feedback to cyclists' heads to inform about the direction and the proximity of surrounding vehicles. To design TactiHelm, two studies were carried out. We started with an online survey to understand cyclist needs and concerns about safety on the road. Then, we designed and evaluated some tactile cues to inform of the distance and the direction of potential obstacles in their surroundings. So why did we conduct this research? Well, the attentional demand of cycling in urban areas is high. Cyclists need to focus their visual and auditory senses to navigate and evaluate risks in their surroundings to avoid collision. Tactile cues can convey information without disrupting visual or auditory senses. Previous research has examined tactile cues for navigation tasks and collision warnings using either handlebars, saddle, and helmet. However, little research has explored tactile support on the head for collision avoidance in cycling. But before we started building our prototype, we wanted to know more about cycling and safety, and especially from the cyclist perspective. So we started our investigation with an exploratory survey. We ran an online survey. We asked 15 questions about the safety equipment participants were using, the strategies participants have to keep awareness of the other road users, and the challenges of cycling safely. The survey was answered by 51 participants from the UK, the US, and from Finland. With this survey, we've learned that more than 80% reported wearing a helmet, but only 26% used cycle lights and only 13% wear reflective clothing. Our respondents also reported concerns about sharing the road with other vehicles. 70% of them perform shoulder checks to scan their surroundings. Finally, if they were given a tactile device, they would expect that it communicates the proximity and the location of approaching vehicles. To address cyclist concerns, we've designed TactiHelm. The aim of TactiHelm is to alert the cyclist of approaching vehicles on the road using vibration cues in the helmet. The cycling helmet is an ideal location for tactile cues as it is widely worn and in contact with the head. To deliver rapid and discernible level of information about proximity and direction, we designed two different tactile patterns. We used a single long vibration for a vehicle at a far distance and two rapid vibrations for a vehicle at close distance. The direction of the approaching vehicle was mapped to the location of the vibrating actuator in the helmet. We ran a user study with cyclists to evaluate the tactile cues perception and identification. 10 participants cycled on a 20 meters outside track. Each time, we triggered a vibration cue using a mobile phone connected to the helmet via Bluetooth. After each ride on the track, we asked the participant what direction and proximity level they associated the cue with. Overall, the identification of the direction and the level of proximity were harder for double than for single vibrations. It was also harder for the actuator located on the back than for the other sides of the helmet. We found a significant effect of the location of the actuators on the identification of the distance and on the identification of the proximity. After the study, all the participants reported feeling comfortable with the helmet. Most participants didn't find any difficulty in remembering the meaning of the cues. They also reported short bursts felt more imminent or urgent than longer vibration.